Good day everyone. Today we're gonna answer a problem here on Fluid Mechanics Chapter 3, Total Hydrostatic Force on Surfaces. Let's start. A circular gate with a diameter of 6 meters is fully submerged vertically under the water with its center 10 meters below the surface of the water. Calculate the force P to be applied at the bottom of the gate, just sufficient enough to keep the gate from opening. The gate is hinged at the center. So we have the figure of the problem here. We have this vertical wall, and this one here is the gate, this blue one, and it is hinged right at its center. This red one here is the hinge, and we are given the diameter of the gate. So diameter, this means our gate is circular. We have 6 meters diameter here, and we have the distance from the surface of the water, which is 10 meters. Our surface of the water is right over here, and we have applied force P here, which is unknown. This is what we will gonna solve, the value of this P. And to solve that, we need to solve first the value of force to be applied by the water on the gate, and this force will be at this going to right direction. So to solve for the value of F, let's say F, the force applied by the water F, we need to write first the given. We have HC is equal to 10 meters. So HC is the distance from the surface of the water to the center of gravity of the gate. And our gate is circular, so the center of gravity is just right here at the center. And we also have a given 3D is equal to 6 meters. Now we will gonna use this given to solve for the value of F, or the force exerted by the water on the gate. So we have F is equal to specific weight times Hc times A, in which this gamma is the specific weight, this A here is the area of our gate, and our area is equal to pi r squared. And now we will substitute the given we have, and the value of gamma is, or the value of the specific weight of water is 9.81, which has a unit of kilonewton per meter cube. And we also have HC, which is 10 meters, and our radius is simply half of a diameter. So we have 6 meter diameter here, so our radius is 3. And then simplifying this equation, we now have the value of force exerted by the water to the gate, 2773.712154 kilonewtons. And to solve the value of P, we need to apply the summation of moment of forces, and we will solve the moment of forces at point here at the center of the gate. And we need to solve first the location of force F, which can be solved using the formula I sub x over y sub c times a, in which this eccentricity is the distance from the center of gravity of the gate to the location of the force F. So we all know that F is located below the center of gravity. So if we get the value of eccentricity, this means that it has a distance eccentricity right below at this center of gravity here. So we have the value of I sub x of a circle is pi r 4/4, and the area of a circle is pi r squared. And we have yc here. Yc is simply, in our problem, yc is simply equal to hc because the wall and the gate is vertical, so hc is equal to yc, which has a value of 10 meters. And then simplifying this equation, we now have the value of eccentricity 0.225 meters. So our force F is located 0.225 meters below the center of gravity of the gate. So our force is located right somewhere here. And now we will apply the moment of force here at the center. Let's say this center point B. And now we now have a formula: summation of moments at point B is equal to 0. And we will assume forces going to clockwise direction as positive. So we have positive P here times the distance from point B to P, which is B is at the middle or at the center of the gate and P is at the bottom. Therefore, their distance is equal to radius, which is 3. Then minus F. We have negative value of F here because it's going to a counterclockwise direction. Then multiplied to its distance from point B, which is 0.225 meters, then equal to 0. We are looking for the value of P here, so we need to transpose this term to the right side of equation. And now we have P times 3 is 3P. And now we have positive F because we transpose this term, F multiplied to 0.225. Substituting the value of F, we have 3P is equal to 27773.712154 multiplied to 0.225. And we are looking for the value of P. So we will divide both sides by 3 so that only P will remain on the left side of the equation. And now we have this equation, and then simplifying using a calculator, we have the value of P, which is 208.03 kilonewtons. And this is now the final answer